In this part of the lecture, we will talk about casting, and first we will discuss the casting of primitive types, for example, the integers and double. We have discussed casting previously in a little bit of detail. For example, we talked about widening conversions and wider assignment, wider casting, and then narrowing conversions. Wider casting means when we cast a value to a wider value, and it is always permitted in Java, but it is not explicitly required. For example, however, if we want to explicitly cast any value, then it makes our code more readable. Let's say we have a variable d that is of type double, and we have a variable I that is of type integer, and we have two more variables d1 and d2. Now in this case, double is considered as a wider value, and if we want to assign an integer value to a double variable, we can do that without any problem. We can do that without losing any information. We can do that without getting any compilation error. The reason for that is, as we can see, that a double value can store more detail, it can store more information than an integer value. That is why Java allows it without any explicit conversion. But if you want to explicitly convert the integer to a double, then we can use this syntax, where for example this is our integer variable int of type int, and this is the type that we want to convert it into, and we are assigning the converted int variable to the double variable. Both of these will work because this is a wider casting where we are assigning a smaller value to a larger value, so we are increasing the capacity of this narrow, let's say, data type to something that can store more detail. That is why it is allowed without any explicit conversion, like in this case. And if we do want to explicitly tell the compiler that we are converting, then for the sake of readability we can do this, but it is not required, as we can see over here. It is permitted without explicit conversion. So this can be called as assignment conversion. We are directly assigning the integer value to the double variable, and now the integer is the value of our integer variable is stored as a double value in our double variable. And this is casting conversion. In this case, this is optional because a double is bigger data type than an integer, and it can store more information than an integer data type can. That is why it is optional, but if for the sake of readability, if you do want to mention it, then we can do it like this. On the other hand, narrow in conversion, in which case we are trying to convert a bigger data type into a smaller data type. For example, a double data types can store more data, more details than an integer or int data type. And if we try to assign a double value to an int data type variable, we might get a compile time error. We might lose some information. For example, this is a double value, and if you try to assign it to an int data type, then as we understand that an int won't store anything that is beyond this point, then we will only get the value 4 and the 0.9, that is maybe an important detail. We might lose this information. And it can be seen with this example that we are trying to store more data in a smaller space. This bottle can hold more data or more material than this cup, and if we try to store larger data in a smaller value, then obviously, as we can see, that we can lose information. The reverse will be of this will be if we try to store the amount that the material of the cup in this bottle, that can the bottle can easily hold to that material. But if we try to store more material in a smaller space, then we might lose information. And we cannot do that by assignment. We cannot do this conversion by an assignment. You must use an explicit cast to convert a value in a large type to a smaller type, or else converting that value might result in a loss of precision. For example, as we talked about this example, D is a double data type and it stores 4.9. I, let's say, stores 10, I1 and I2 are int data types. If we try to do conversion by assignment, that will not be allowed by the compiler. We will get an error, maybe data type error or something like that. Assignment conversion compile time error will be produced. If we do need to convert this double value to the int data type, then we can do it explicitly by following the syntax of casting. And this is narrow casting. What would happen is we have stored this value D. The value of D was 4.9, but if we store it in an int data type variable, then we will lose anything that is beyond this decimal point. Everything beyond the decimal point will be truncated, and that is we need, that is where we need to be careful, that we might lose information if we are trying to convert from a larger type to a smaller type. We can see this chart, for example, which variables or which data types can lose information and which cannot lose information. If we are converting an int to a double, that is a wider type conversion and we do not need casting explicitly. And if we are converting a double to an int or anything beyond this point, then we do need casting. For example, a conversion of a character into an int will need casting. Conversion of a short to an int will not need casting, but the reverse will need casting. So whenever we are trying to convert a larger value to a smaller value, we will explicitly need casting, and we need to keep in mind that we might lose some detail whenever we convert from a larger value to a smaller value or smaller type. To talk about casting in objects, casting an object to a different type will permit access to fields shadowed by the type of the original object. Now we have used casting in objects in our previous lecture, where we converted an object of superclass to an object of subclass. And the reason for that conversion was, if we want to access an object, for example, if we want to access a method of the subclass, then we cannot do that with the object of the superclass. If we want to access a method in the subclass, then we have seen that in our previous examples as well, that we cannot do that with the object of the superclass. For that access, we will need to convert the object of the superclass into the object of the subclass, where that method has been declared and defined. Then we will be able to access that method with that object. So casting an object to a different type will permit access to fields shadowed by the type of the original object. So for example, if we are not able to access anything with the original object, then we may be able to access those fields by converting that object to a different type. Now we can only convert to objects of compatible types. We talked about compatibility when we were in the lecture of instance of operator. So the objects need to be compatible in order to be converted or casted. Otherwise we will get a compile time error. Casting an object to a different type will have no effect on which method it is invoked in response to a given message. Once overridden, methods remain overridden. Casting will only affect the type of the object. It will not affect the type of the method that is being called by that object. The object or the method will remain the same. It will not affect the overriding of the method even if it is being has been declared in the subclass. It has been overridden once and it remains overridden. To cast, just precede a value with the parenthesized name of the desired type. As we saw in our primitive type conversion, we can do the same, and with the objects as well. We need to write the name of the class that we want to convert the object to in parentheses, and then we will be able to convert that object. We'll see it in the example. A class cast exception is thrown if the type cast is incompatible with the type of object to be pointed to. As I said that we only can convert objects that are compatible with each other, and we have seen that what compatible objects can be. Those are objects which are related in an inheritance relationship, and we discussed in detail when we were talking about the instance of operator that what can are compatible or incompatible objects. So we can only convert between incompatible objects. If the objects are not compatible, then we will get this exception. Exceptions are the kind of errors that we get when we go into some problem. We will talk about exceptions in the next lecture in detail, although we have been using exceptions at a small scale in our code so far. To check that a potential cast is safe, the instance of operator should be used. And we use this in our instance of operator example in our lecture 16, that when we were trying to confirm if the objects are compatible with each other, we can check that through the instance of operator. It will check if an object is an instance of the other object, then possibly it can be converted, otherwise it will not be converted. The instance of operator can be used to determine the type of an object. It returns a boolean value. It returns true if object can be assigned into a reference of type, for example class name. That is, instance of checks if the object is an instance of the specified class, provided obj is not null. You can look into the instance of operator lecture if you want to go into the detail of this. It basically checks if an object is a reference type of a class, where when we were using polymorphism, for example we stored all the objects in an array of a superclass. Then if we were looking for an object of the subclass, we were able to do that with the help of the instance of operator. If it will check if the object is an object of the subclass, this class name will be the object of the will be the subclass that we want to compare it with. We want to check if the object belongs to this subclass, then it will be it may be converted or convertible. Otherwise, if it is not, then it will not be converted. And this is the syntax of the instance of operator that we have seen previously. Here we'll write the name of the object, the instance of keyword, and the name of the class. That will return a boolean value. We have some conversions, type of conversion, widening conversion and narrowing conversion with the objects, as well as we saw in our primitive data types. And wider object can be simply done through assignment conversion, or we can do it with reference casting as well. But as we can see that we have an object of the superclass, then we declare an object of the subclass. As we can see this hierarchy over here, this superclass is the wider type and the subclass is the narrower type. So it shouldn't be not a problem if we assign an object of the subclass to the object of the superclass, but the reverse will not be as simple. So as we can see that we have declared an object of the subclass and we can assign it to the object of the superclass because it is a wider conversion and we will not get any error for this. But as we understand that we cannot access the methods or any fields of the subclass inside through the object of the superclass. So we need to we have been talking about since our previous lectures that we are not able to access the fields of the subclass through the object of the superclass. We can do the conversion or casting using this syntax as well, but it will make no difference to the compiler. Widening casting conversion, it is okay, however no access to fields in derived. Reference conversion, like primitive conversion, takes place at compile time because the compiler has all the information it needs to determine whether the conversion is legal. As I said that it is checked at the compile time. If you remember from our discussion of compatibility between objects, you are getting a compile time error if you are trying to convert or assign incompatible objects to each other, and that will be done at the compile time. We will get an error if we try to convert an object to another object that are not compatible with each other, and the compatibility is usually determined through the inheritance relationship. Inheritance relationship is a relation. The parent object is more general than child object. That means that the parent object is the wider type and the conversion is straightforward. It can be done through simple assignment. The general rule of thumb is that converting to a superclass is permitted because superclass is wider type than subclass. But if we try to do narrow in conversion, direct assignment will result in compile time error. Narrow object reference assignment will result in compile time error, and we have seen this. Narrow object reference casting, on the other hand, it can be compile time okay, but at runtime, like primitive casting, by using a cast, you convince the compiler to let you do a conversion that otherwise might not be allowed. The runtime check determines whether the class of the object being cast is compatible with the new type. So if we try to convert through assignment directly, then we might get an error right at the compiling time, at the time of compilation. But if we use, for example, narrow object reference casting with that parenthesis using the syntax, then we might be able to go through the compiler, but then again it will be checked through the runtime that if the objects are compatible with each other or not. Again, if we look at our example, we have object of the superclass and we have object of the subclass, and then we have a few objects or variables of our subclass. Now in this case, the simple conversion or assignment is not allowed. We cannot assign an object of the superclass to an object of the subclass, as we have been saying that object of the subclass are object of the superclass, but the reverse is not true. We can do this by using this syntax. Now this will convert this object of the superclass to the object of the subclass. There are situations that we need to do this. There was a question in your mid exam. I'm not sure if most of you were able to get that, but you were asked to, for example, increase the price of the kitchen item, and what you were supposed to do was, for example, if you have an array of the superclass variables and those that array is storing the subclass objects, and if you want to access a specific object, subclass object, then you can use the instance of operator first to get the object, and then you can convert the object to an object of the subclass to be able to access a method that is specifically or exclusively defined in your subclass, because we cannot access our subclass methods through our objects of the superclasses. That is why in those situations we need to convert our objects of the superclasses into object of the subclass so that we can access our subclass fields. Now this will obviously give us a compile time error because we cannot assign an object of the superclass to an object of the subclass. We can do this by conversion using casting. Compile time OK, runtime error, maybe B is an instance of class base, not derived. So we might get this error if there is no relation between the classes. Now to avoid the compile time error, this is what we can do. We can declare the object of the subclass with the superclass reference, and that is what we do in our polymorphism as well. That is what we do in polymorphism, that we declare all our subclass objects with the superclass reference. Now in this case, if we try to use this conversion again, now this was okay at compile time, but at runtime this might get an error because these are completely separate objects. The subclass object is not initialized using the superclass reference as we have done over here. That is why we get a class cast exception. Now to avoid that error, what we can do is we can initialize our subclass objects through the superclass reference. Then we can convert those objects whenever we need to our subclass. Now the difference between this object and this object is that although these are our subclass objects, this one is with the superclass reference. Now the difference is that this object will not be able to access the fields in the derived method that are explicitly declared in the derived method, but this one D3 will be able to access the methods of the derived class, and that is why we need to convert sometimes the object of the superclass into our subclass objects.